sudden change in acceleration is called a jerk.
Did you draw a graph of this jerk? Sorry, I guess there wasn't supposed to be a comma in that. What's the function for this jerk? For the jerk in this case? What is it here? I know it has a 5 involved. 5 sine t. It is the derivative of acceleration. It's the rate of change of acceleration. If we are measuring this in, did I put some units up there? 5 units, okay. The position is measured in units. The velocity is measured in units per second. The acceleration is measured in units per second squared, or units per second, and the jerk is measured in units per second cubed. It's units per second. It is, right? It's how fast the acceleration, it's the rate of change of the acceleration. It is, what did we say, 5 sine t, so it's this. Think about when the maximum jerk is happening. The maximum jerk happens when the position is what? In the middle. This is the original function here, when the position is at 0, right in the middle, right? This is when the most positive jerk is happening, when it's in the middle on the way down, right? Does that make sense? Well, if you look at, this is the graph of j of t, right? The acceleration is changing in positively the most when it's in the middle on the way down. Jerk prime. Jerk prime. Not that, I don't know if it has a name. The fourth derivative? I don't know. I don't know. You come up with your own name. That can be your exercise for next Wednesday. No, remember, this is a G-rated video here, okay? You're going to have to do that on your own time. No, it's not.
To the limit.
When is the... we have... Yes. When is the... When is the jerk the highest here? When is the jerk the most positive? Right here on the way down, right? This is where it's changing. This is where the acceleration is changing in the positive direction the most. Right? Because the acceleration at that point is changing from negative to positive. The acceleration is negative. It's becoming positive. At this point, that's where the jerk is the highest. It's because the acceleration is having a change the most that way. When it's going the other way, okay, down here, this is where it's the most negative because this is where the acceleration is changing that direction. It's hard to wrap your head around what that means. Okay? There's zero jerk at the beginning, which means for that instant, the acceleration is not changing. Right? You notice the acceleration is not changing. The rate of change of the acceleration is 0 at that point, right? And at this point. The acceleration is not changing when it is at its extremes. When it's at the top or the bottom. Okay? The velocity is changing. The acceleration is not changing. It's hard. I know it's hard. Okay? Can you do some of the problems that we have here? We already did this. We already said, I think, hopefully you realize if you have a projectile launched in the air and it's a quadratic, right? Something t squared plus something t plus some initial position, right? Negative 4.9 t squared if you're doing it in metric plus 1,000. You launched it at this incredible vertical velocity, meters per second. and you launched it from the top of 2 feet, 0.5 meters. If that's your a function for the height, if you're using h, or s if you're using position, if you want h prime, okay, if this is h of t and you want h prime of t, it is going to be negative 9.8 t plus 1,000. The velocity function comes from two places. The original function comes from three things. The height of the object at any time comes from three things. It comes from the effect of gravity, that's this term. It comes from the effect of whatever initial velocity you give it. You give it more initial velocity, the higher it'll be at any time. And it comes from the initial position, that constant. H prime, or in other words, the velocity comes from two places. The initial velocity you gave it, plus the effect of gravity. If you look at the acceleration, a prime of t, which is h double prime, getting ahead of myself here, h double prime, I'll try for a third time here, h double prime, or v prime, what's that going to be? Just negative 9.8. If we're ignoring wind resistance and all that stuff, you have a constant acceleration. Okay? That means you have a zero jerk. You have to be very careful how you put the punctuation and the emphasis when you're describing, when you're saying sentences that involve the third derivative of position. You know, you can offend somebody if you put an extra comma here or emphasize the wrong word or syllable in your sentence. Can you find the third derivative? Jerk? I mean, if you put a comma in there, you know, or you don't put a comma, I don't know. What? Is he insulting me? I don't know.
Peter's a jerk.
And then where's that from? I am going to put a stop to this.